You are given the graph of f prime. We're going to sketch a graph of the function and the second derivative. Whoa, okay. Let's pay attention to horizontal placement of maximums and minimums, x-intercepts, and whether your sketches should be positive, negative, increasing, or decreasing, many possible answers. I'm going to jump into the first problem with something that I think is fairly obvious. And if this function that I will represent right here by calling it what it is, this is the derivative, then I can very easily find the second derivative by just talking about the slope. What's the slope of this line? Clearly a line, okay? Let's assume it's a line. If it looks like a line in this context, it's a line. You can't always assume it, but this time, yeah. So what is the slope of that line? I agree. I'm glad you said that. I'm going to graph my second derivatives in green, and that slope is indeed pi. I'm kidding. It's -1. So -1. There we go. And this, my friends, is the second derivative. Okay, we have just graphed the second derivative. Now we're going to find the original function. Whoa, what? Huh? Okay. This was linear, right? Right? Right. Okay, good. Because it was linear, we got linear derivative by taking the derivative of what kind of function? Okay, if you need a refresher, we're here. I think it's fairly obvious, I think, and if it's not, that's fine. We got a derivative that was linear, therefore we had a quadratic. So in a minute, we're going to draw a parabola on here somewhere. That parabola, I'm going to just start listing things about it in blue. My original function is going to be blue. F. I'm just writing things about F that are good to know. F has a vertex at what x value? Okay. The derivative of F is equal to 0 at the top or the bottom, maximum or minimum vertex in this case. So when I have a, here we go, first page, maximum, the derivative equals 0. If this would have gone the other way, and I would have had an x value there, it'd be there, same thing, okay? X equals 1. I'm going to write reasons too. You don't have to write all this, I'm just explaining it and I want you to see what I'm saying. F of x has a vertex at x equals 1 because f prime of x equals 0 at x equals 1. I could have said f prime of 1 equals 0. That would have been the same thing, okay? I was a little wordy, sorry. So now the question is, does my parabola, and I'm switching to a very light colored pencil, does my parabola open downward or does my parabola open upward? And then there's another question too. Well, we'll get to that other question in just a minute. Because the question that might be on your mind is, well, maybe my parabola is here, but maybe my parabola is here, or maybe my parabola is here. We'll talk about that, okay? We'll talk about where that parabola actually is, if we can even know where it is. But for now, let's just address a simple question. Does this parabola open up or does it open down? Okay, so let's see. The derivative, I'm writing my thoughts in blue because we're going to graph this thing in blue. The derivative is positive for x values less than 1. Okay? Therefore, you've seen this before. Triple dots means therefore. Therefore, f of x is increasing on that same interval for the values that are less than 1. You could say negative infinity to 1, okay? Let's take that idea and run with it. So there's one idea. Here's another idea. The derivative is negative for x values that are greater than 1. Therefore, you know where this is going, the original function is decreasing for x values greater than 1. So we need a function that increases until we get to 1 and then decreases afterwards. So is it upside down or right side up? We need increase then decrease. I think we've chosen it correctly. It is this one, not this one. I'm going to erase. So now we have a couple more questions. And here's one of the questions, and I just addressed it. Is this parabola going to go like this, or is it going to do the same thing down here? Is it going to do the same thing here? Is it going to do the same thing here? Well, let me show you something on a scrap piece of paper that I don't have. Yes, I do. Do I? Yes. No. But you'll see the corner of another piece of paper. If I took the derivative of a quadratic, I'm just making up a quadratic right now. Let's just say that I have f of x equals, and because it's upside down, we'll go with negative x squared. I take the derivative of that, and I would get negative 2x, okay? Now, technically, this is not the same derivative. That's negative 1x. So if you want to get technical, it would really be that. That's really what I'm dealing with here, if you really want to get technical about it. So the derivative of this would give me that. Well, then the question is, why'd you pick 5? Does it matter what I pick? Maybe it's 50. Maybe it's 1 over 50. Maybe it's negative 1 over 50. Maybe it's negative 111 over 50. This number goes away, and that is a vertical shift, okay? Now, there are other things in this. There's other stuff. It slid horizontally and all kinds of stuff. But the idea I'm getting at is this. This constant doesn't matter. That is a vertical shift. So the derivative of this line, this parabola, is the same as the derivative of this parabola, same as the derivative of this parabola, so it doesn't matter where you draw it. Now we get into another question of, is my parabola this, or is my parabola this, or is my parabola this, or is my parabola, who knows, okay? At this point, we're getting deep into speculative territory. Actually, we can know. I am going to pick a random point. I'm going to start it here because I want to. And because I happen to know, and again, we're getting into territory that's not necessary, but I'm going to play there anyway. Because I know it's negative 1/2, that would give us a negative 1x. And again, there's a horizontal shift that we're ignoring, but it's okay. Because of that negative 1/2, I could go over and down a half and over and down a half. And don't panic about that, and it's not going to be a huge deal, but it's basically that. Well, Mr. Reader, I don't like your graph. That's okay. You don't have to. You don't have to draw it where I drew it. You could draw it down here if you wanted to. Do you draw it steeper? Do you draw it thinner? Technically, mine has the right steepness, at least at first, but I'm not going to be picky about that. There we go. Any of these are correct. And I'm not going to really be too picky about this parabola versus this parabola versus, well, that's a little crazy, but you know, you get my drift.